Today, I will be presenting on data acquisition tools in computer forensics. Data acquisition is one of the most critical stages in any forensic investigation because it preserves the integrity of digital evidence before analysis begins. In this presentation, I will discuss the purpose of acquisition, major vendors in the industry, technical features, pricing models, real-world applications, and how acquisition directly impacts legal admissibility. Data acquisition is the formal process of collecting digital evidence from a storage device in a way that preserves its integrity and authenticity. In digital forensics, this is the foundation of the entire investigative process. Every artifact analysis, keyword search, and timeline reconstruction depends on the quality of the acquisition. Unlike simple file copying, forensic acquisition must ensure that no data is altered during collection. The goal is to create a reliable duplicate of the original media so investigators can analyze the copy while preserving the original as evidence. If this initial step is flawed, every conclusion drawn afterward becomes questionable. That is why acquisition is not just technical, it is procedural and evidentiary. The reason acquisition matters is because of its direct connection to legal admissibility. Under evidentiary standards such as Federal Rule of Evidence 901, digital evidence must be authenticated. That authentication begins with proving it was collected properly. Investigators never analyze the original drive. Doing so risks modifying metadata such as timestamps or system logs. Instead, a forensic image is created and verified, and analysis is performed on that duplicate. Acquisition also supports chain of custody documentation, which tracks how evidence is handled from seizure through courtroom presentation. If acquisition procedures are incomplete or undocumented, opposing counsel can challenge the reliability of the evidence. In digital forensics, the strength of the case depends on the strength of the acquisition. There are two primary forms of acquisition: logical and physical. Logical acquisition captures files that are visible to the operating system, such as active documents and directories. It is faster but may not include deleted or hidden artifacts. Physical acquisition, often referred to as bitstream imaging, captures every sector of the storage device at the binary level. This includes deleted files, slack space, unallocated space, and residual data. To ensure the integrity of the forensic image, cryptographic hash functions such as MD5 or SHA-256 are applied to both the original device and the duplicate. If the hash values match, the image is verified as exact. Write blockers are used to prevent any modification of the source media during imaging. Together, these safeguards ensure forensic soundness and evidentiary reliability. The five tools presented represent a spectrum of deployment environments. FTK Imager and Autopsy provide accessible imaging capabilities suitable for academic and smaller investigative settings. EnCase and Magnet Axiom represents enterprise-level solutions used in large law enforcement and corporate forensic labs. ProDiscover occupies a middle ground, offering structured acquisition and analysis for moderate-scale environments. While all five tools support bitstream imaging, their differences lie in automation, reporting capabilities, and scalability. All five tools support core acquisition functions such as bitstream imaging and hash verification. However, their differences become more apparent when evaluating operating system compatibility, automation, scalability, and integration with broader forensic workflows. FTK Imager is straightforward and highly effective for disk imaging, particularly in field environments. It is lightweight and easy to deploy, but it does not provide full case management capabilities. EnCase is more robust and designed for enterprise environments. It supports scripting, detailed reporting, and integrated evidence management, which makes it particularly suitable for courtroom proceedings. Autopsy, being open source, provides flexibility and extensibility through modules. It requires more configuration but offers strong disk analysis capability across multiple platforms. Magnet Axiom emphasizes modern investigations, especially those involving mobile devices and cloud artifacts. It automates artifact parsing at scale. ProDiscover offers structured workflows but is generally better suited for smaller investigative environments. Ultimately, while all tools can acquire data, their strengths differ based on investigative scope and operational requirements. This matrix evaluates five digital forensic acquisition platforms across four critical dimensions: budget, organizational scale, technical complexity, and primary operational use case. Starting with FTK Imager. This tool represents the lowest budget entry point as it is freely available. It is most appropriate for individual investigators, academic environments, and field acquisition scenarios. While while technically less complex than enterprise suites, it provides reliable bitstream imaging and hash verification, making it highly valuable for initial acquisition. EnCase, by contrast, represents a high-budget enterprise solution. It is widely used by federal agencies and large investigative labs. Its complexity reflects its depth, offering full forensic workflows, scripting capability, integrated evidence management, and detailed reporting structures designed for courtroom admissibility. EnCase is optimized for criminal prosecution environments. Autopsy is open source and cost effective. It scales well for academic programs and smaller investigative teams. While not as commercially polished as enterprise tools, it offers strong disk analysis and capabilities and extensibility through modules. Magnet Axiom operates at the enterprise level, but differentiates itself through modern forensic capabilities. It excels in mobile device analysis, cloud artifacts, and application level parsing. Its deployment model is subscription based and designed for large scale digital evidence processing. Finally, ProDiscover occupies a middle ground. It is moderately priced and suitable for small to mid-sized organizations. It offers structured acquisition and analysis workflows, but lacks the expansive ecosystem found in Encase or Axiom. Collectively, this comparison illustrates that tool selection is not purely technical. It must align with budget constraints, investigative scope, and evidentiary requirements. Legal integrity in digital forensics depends on three foundational elements: hash verification, write blockers, and documented chain of custody. Hash verification confirms that the forensic image is identical to the original media. If the hash changes, the evidence is considered compromised. Write blockers prevent any write commands from altering the source device during acquisition. Even small system-generated writes can modify metadata and undermine evidentiary credibility. Chain of custody documentation tracks who handled the evidence and when. Together, these procedures ensure that the acquisition process can withstand courtroom scrutiny. Modern storage technologies introduce new complications for forensic acquisition. Full disk encryption can prevent access to data unless the encryption key is captured while the system is live. If the device is powered down prematurely, critical evidence may become inaccessible. Solid-state drives use trim functionality, which can permanently erase deleted data blocks shortly after deletion. This reduces the recoverability of artifacts compared to traditional hard drives. Cloud storage presents jurisdictional and logistical challenges. Evidence may reside on remote servers controlled by third-party providers, requiring legal coordination. Mobile devices further complicate acquisition due to proprietary operating systems and rapid application updates. These evolving technologies require investigators to adapt acquisition strategies while maintaining forensic soundness. In a documented criminal investigation, forensic analyst Barry Friedman used Encase to acquire and analyze a suspect's hard drive in a child exploitation case. This process began with proper forensic imaging of the device, ensuring that the original data was preserved. From that image, investigators were able to recover more than 14,000 illicit files. To ensure the evidence was reliable, hash verification was used to confirm that the forensic image matched the original device exactly. This step is crucial because any change to the data could make the evidence inadmissible. If any of these steps had failed, the evidence could have been challenged or dismissed. Because the acquisition process was properly documented, verifiable, and forensically sound, the evidence was accepted in court and contributed to a successful conviction. This case highlights an important principle in digital forensics. Finding evidence is not enough. It must be collected in a way that is defensible and can withstand legal scrutiny. No single forensic tool is universally superior. Each platform offers strengths tailored to different investigative environments. Free tools provide accessibility and educational value. Enterprise tools provide automation, scalability, and structured reporting. However, regardless of the platform used, the investigative outcome ultimately depends on adherence to forensic principles. Proper acquisition preserves evidentiary integrity, supports legal admissibility, and establishes investigative credibility. Digital forensics begins with acquisition. Every artifact analysis, timeline reconstruction, and courtroom presentation depends on the integrity of that initial step. If acquisition is incomplete or improperly performed, even compelling evidence may be challenged or excluded. When performed correctly, acquisition establishes trust in the investigative process. In digital forensics, evidence is only as strong as the method used to collect it. That is why data acquisition remains the foundation of the discipline. Thank you.